Okay, today we're going to do connected rates of change. Okay, and the main concept behind connected rate of change is this. For example, if we have the rate of change of y with respect to t, okay, it simply equals to the product of dy dx, okay, multiplied to the rate of change of x with respect to t. In a way, if you can see, right, it's as if, right, the dx and dx are being eliminated to get dy dt. Alright, so that's the brief concept behind connected rates of change, but not to worry so much. I'll dive into an example immediately so that it's a bit easier for you to get the concept. So without much further ado, I'm going to work in exercise 15.4, okay, and I'm going to talk about question 1b. Okay, for 1b, they tell us that y is equals to 3 over 2x minus 3 cubed. And what they want us to find is if the rate of change of x is 2 units per second. So the information I have is rate of change of x is 2 units per second. Alright, and I also know that at x equals to 2, okay, and the question they want is find dy dt, or rate of change of y with respect to t. As we have learned above just now, so the rate of change of y with respect to t is equals to dy dx times dx dt. Okay, the only thing missing now is probably dy dx, so let's start with y equals to 3 times 2x minus 3 to the power of negative 3. So differentiating this, okay, with the applied chain rule, so it's negative 9, 2x minus 3 to the power of negative 4 times, you differentiate inside the bracket, you get 2, so you get negative 18, 2x minus 3 to the power of 4. Okay, now simply connected rate of change to find dy dt is equals to dy dx, okay, which is here, negative 18, 2x minus 3 to the power of 4. Okay, in this case, is 2x minus 3 to the power of 4 times dx dt, which is 2 units. Okay, then I also know that my x value is 2. Okay, from here, 2 times 2 is 4. 4 minus 3 is 1, so I get 1 to the power of 4, okay, multiplied by 2. So my rate of change of y with respect to t is negative 36 units per second. So that means y, okay, at this moment of time when x equals to 2, okay, it tells me that my rate of change of y with respect to t, okay, is equals to is decreasing at 36 units per second at that exact moment in time. Okay, now let me carry on. I give you another example. 2c. 2c, y is equals to 2x plus 7 to the power of half. Okay, and what other information do I know? Okay, the rate of change of y is 4 units per second. So now in this case, I have rate of change of y with respect to t, okay, is equals to 4 units per second. And the question is actually asking us to find dx dt. Whoops, okay. So now, first and foremost, we start again. Okay, first we differentiate this. We know that we need it soon. dy dx is equals to half times 2x plus 7 to the power of negative half. Okay, don't forget to differentiate inside bracket is 2. Half times 2 is 1. So I get 1 over square root of 2x plus 7. Now I will find dy dt equals to dy dx multiplied to dx dt. Okay, just submit values that we know. dy dt is 4. dy dx, alright, okay, dy dx. Okay, dy dx in this case is equals to 1 over square root of 2x plus 7, okay, times dx dt. Dx dt is the unknown down here. Okay, and then I know that in this case, alright, they give us that the y value is equals to 3 down here. Notice that down here I'm a bit stuck already. Notice I have a y value, but I don't have a corresponding x value. So what do? Looks like I need to go and look at these two friends, okay, down here from my original equation, and my y equals to 3 down here to get a corresponding x value. So at the side here, what I do here is this: I let y equals to 3 into this equation. 3 is equals to square root of 2x plus 7. Square both sides, you get 9 is equals to 2x plus 7. 2x is equals to 2, x is equals to 1. Now I got appropriate x value equals to 1. I can substitute it back here and say 4 equals to 1 over square root of 9. Okay, square root of 9 is 3. So if you multiply both sides by 3, you get 4 times 3 is 12 equals to dx dt. So I say therefore dx dt is simply equals to 12 units per second. Alright. Okay, just do for you one more question, question 7. A. Okay, 7a. And 7a works like this. Okay, they tell you that the area of a square increases at the rate of 10 cm square per second. So just write down whatever you know. Okay, so you say let area be a. Okay, so I know that dA dt is equals to 10 units cm square per second. Then they tell us that the rate of change in the length of the square when the area is 4 cm square. Okay, so I say let side of square be, maybe x and call it L, up to you. Okay, now this question requires a bit more thinking, but just follow me here and let's just do it slowly. First, right, we have to relate the area to the side of square. We know that area is equals to x square. Can? So now based on this, right, I know that I can find dA. I differentiate a with respect to x is equals to 2x. Notice you got dA dt, you got dA dx, and they want you to find the rate of change or in the length of its side. Okay, basically what they want you to find is to find dx dt, rate of change of the side of the square, okay, when area is 4 cm square. Can? So I use this piece of information first. When a is equals to 4 cm square, I substitute it into here. Okay, so I say that a is equals to x square, 4 equals to x square, x is equals to 2 cm. Okay, now what we need to do here is this: I need to relate everything down here. Okay, so now we start, this is like y, this is like x, so I'll say that dA dt, this one, is equals to dA dx. Okay, just bear with me. Okay, dA dt, okay, is equals to dA dx times dx dt, like this. Okay, what we had just now was dy dt equals to dy dx times dx dt. Now we're just replacing a with y, so no need to get too confused there. Then I will move on to the next piece of paper. I fill in the values that I know. My dA dt, okay, is equals to 10 cm square. My dA dx is 2x times my dx dt. Dx dt is the unknown. However, you do know the value of x as we calculated just now. Then we sub x is equals to 2. So I get 10 equals to 4 times dx dt. So simple manipulation will help me to find that dx dt is equals to 10 divided by 4 is 2.5 cm per second. That means the length of the square is increasing at 2.5 cm per second. And that concludes my examples, okay, from 15.4. Thank you for watching.